What is up, calculus students? We are talking about asymptotes. First start is to write 4 total limit statements, just showing that you understand asymptotes using limits. So we can see there's a vertical asymptote at x equals 5, and we have a horizontal asymptote at y equals 3 and y equals negative 3. Our goal is to be able to understand that a vertical asymptote, our function is trending towards the positive and the negative infinities for our y's. So I would say the limit as x approaches 5 from the left of the function equals positive infinity. If I'm to the right of 5, I'm going to approach negative infinity. And then for the horizontal asymptotes, I can see if I go towards negative infinity on my x direction. This is just gross. I'm like not in a good position to use my slate. If I'm going towards negative infinity in the x direction, my function is going towards positive 3. And if I'm going towards positive infinity, my function is going towards negative 3. I had a fun time when I created this homework, like thinking about the functions that would have this kind of shape. So like I had to think and play around a little bit. All right, I can see we have a vertical asymptote at x equals negative 1. The limit, therefore, as x approaches negative 1 from the left, and the limit as x approaches negative 1 from the right is what I'm looking for. I can see if I'm to the left of negative 1, my function's going down towards large negative values. If I'm to the right of negative 1, my function's going up. If I look at horizontal asymptotes, there really is only one horizontal asymptote, but I would want you to discuss both end behaviors. You can see if you went out to x equals negative infinity, your function is trending towards this y equals 0 line. Versus if you went out to positive infinity, your function is going to infinity. So when we look in these directions, we could get numbers, we could get infinities, we could get zeros. If we're looking to the left and right of a vertical asymptote, we're just getting infinities. This is an interesting one. In this situation, I can see we have a y equals 4. We have an x equals negative 2. So for the vertical asymptote, I can see to the left of negative 2, I'm going up towards positive infinity. To the right of negative 2, I am down here at negative infinity. Vertical asymptotes don't have to be in different directions. You could have the function coming from up there as a potential. So just know that. Then if I go and plug in negative infinity, I can see that my function is going up towards positive y. So I would say this is positive infinity. And if I'm going off to the right, I can see my function is trending towards the y value of 4. Okay, that's the idea behind being able to write up limit statements so you understand what is going on. Okay, now we are starting with evaluating limits at infinity. So plugging in infinity. What are we finding? We are finding the end behavior or the potential horizontal asymptotes. We have a function, we look all the way to the right and all the way to the left. What is the function's end behavior doing? Now, we talked about in class. Understand more, memorize less. We're not memorizing something. Rather, we are identifying situations conceptually with infinity. How certain infinities are bigger than others or faster than others. Infinity squared times 5,000 is a slower infinity, a smaller infinity than infinity cubed. If I encounter something where I have slower over faster, think about what happens when you have slower growth in the numerator and faster growth in the denominator. Each subsequent fraction gets smaller and smaller and smaller. If we flip and we see faster growth in the numerator, slower growth in the denominator, we could see it would just be the same situation, only flipped. We can see each subsequent fraction gets larger and larger and larger. So this would be positive infinity. Careful about signs, maybe we could have a positive or negative. And that's what we have to worry about here. We do have a faster over slower. However, a negative value cubed would be a negative, but a negative value squared would be a positive. So maybe, and it's not because we have negative, it's just because of these signs, we get negative infinity. For example, if I put x to the fourth here, if I put x to the fourth over x squared, I would say it would be positive infinity. It'd be a positive over a negative. Now, what if we have the same growth? Well, the growth is going to cancel. Now, for this example, I have this negative 4 times 1 over 1, and then a negative 4 times 10 over 10, and then a negative 4 times 100 over 100. It's essentially like these can cancel. Now, this is with like ones where it's just one term, but when we start talking about multiple terms, we'll talk about how certain things are insignificant and we can just forget about them. Okay? So this is a negative faster. So this is a negative 4 times a negative faster over a positive slower. Because it's a negative squared. So I'm going to say this is a positive faster over slower, which is going to be positive infinity. Log x is the slowest growing function. E to the x, exponential functions are the fastest growing functions we'll deal with. However, only in one direction. In the other direction, we talked about how they're zero. So this is a slower over faster situation, which will be that, which will trend towards zero. Exponential functions in the positive direction, fastest growing functions that we deal with. So this is definitely a fast over a slow. So this is going to be infinity. But exponential functions going in the negative direction actually will create a no growth function or just zero. This will be like an infinitely small number. So this is like either slow over fast or no over fast. Regardless, this is going to be zero. A lot of people think this is the same growth over the same growth. This is wrong, 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 wrong. 5 times 5 times 5 would produce slower growing numbers than 6 times 6 times 6. It's not like all of these cancel and just leaves you 1, 5, 6. This is going to be a slower over a faster. Same would be here. You have to know the value of e is 2.7, the value of pi is 3.14, so this is a slow over faster. Now we have a same over a same. So the e to the x growth will cancel with the e to the x growth, and I'll just leave us with the 3 halves. It's almost like we can cancel these and just get 3 halves. What about 2 times 5? Is that 10 to the x? It is not. This is not faster over slower. This is 2 times 5 times 5 times 5 times 5, which is not going to be nearly as big as 6 times 6 times 6 times 6. So we can see we're just going to continue to multiply by 5, 6, and that will be a slower over faster. Now, we talked about in class, what if we're adding some other stuff? Well, if I plug in infinity, then I'd have 2 times infinity squared plus 299 times infinity plus 1, 2, 3, 4, 5. What we talked about in class is that when dealing with infinities, the fastest growing infinity eventually will be so much bigger than slower growing infinities that you can ignore them. It's like adding a very, very small number to a very, very large number. So I really just look at 2x squared and 0.1x cubed. This is going to be slower over faster. All right, so I don't care about that. It'll be a much smaller number compared to that. It'll be insignificant. I don't care about the 99. It'll be insignificant. I care about the negative infinity being cubed. So I have like a negative faster. over a negative slower, or you could see like if you cancel the x, you'd get like x squared. But I like to do this just in case we can't cancel. So negative faster over a negative slower would be a positive infinity. Here, the 200 will be insignificant. It'll be like adding a very, very small decimal to a very, very large number. If I plug in infinity, I'd have a negative faster, negative slower over faster. We don't really care about negative slow over faster because we're approaching zero. And we could be asked like positive or negative, like coming from the negative side towards zero, zero from the left or zero from the right, but we're not going to worry about it. Okay, still talking about positive infinity, no growth. This is no growth. Sign just goes up and down and up and down. It doesn't grow. So we have a same over same, so the growth will cancel. Okay, first one we're going to all trip up on. Everybody, heads up. Everybody, heads up. Y'all are going to get this wrong. You're going to think that it's 6 to the x over 3 to the x. You're going to think it's faster over slower. You are wrong. Since it's negative infinity, 6 to the negative infinity is like dividing by 6 infinitely many times. This is approaching 0. Negative infinity takes exponential functions and makes them 0 or no growth. And we all of a sudden realize that the answer is a same over a same. That's the first one that's going to trip a lot of you up. This one's another one that trips you up. You could either distribute this early on and see that you have like 6x squared plus a bunch of stuff that won't matter. Or you could actually say that negative 1 and that 2 doesn't matter and you just have really 6x squared in the end that matters. In the denominator, we set the negative 5x squared. Well, we realize it's a same over same situation. The growth will cancel. You'll have this negative 6/5. Okay, back to this similar one. Oh, I think my thing just like got funky. Oh no. Might have to like close out and open it back up or just suck it up. If I plugged in infinity, okay, now the exponential functions are very important. Now, this is very important. 6 to the x is faster than 3 to the x. That means we have a negative faster over a positive slower. The negative faster over the positive slower will give us a negative infinity. Let's try to close this out and open it back up. What I don't want to have to do is like restart this computer because then that would be a disaster. Ooh, can I finish this homework in 35 minutes? I would hope so. Can this homework open? Nothing's working. Oh, shit. Come on. Oh, it's a disaster. I can't even pause the recording. I don't know what happened there. I guess it's recording the fact that, I mean, it should be fine. Let's see. Sometimes if I do that, everything fixes itself. Okay. Sorry for the delay. See if this works. We're at this one in the bottom middle. Okay. Nope, doesn't work. I have to restart my computer. I'm just going to suck it up. If I plugged in infinity, this is the slowest. This is slower. This is slower than that. This is a slower over faster. What happens here? Well, like, careful crossing things off. In this fraction, the 200 goes away. This would be 3 plus slower over faster. Well, 3 plus slower over faster is 3 plus 0, so the answer is actually 3. I think there's a number that's supposed to be here. Regardless, that number goes away. This is another interesting one. What if I plugged in infinity? Would be the cosine of slower over faster. And when you get the cosine of slower over faster, well, that's the cosine of 0. What's the cosine of 0? How many of you are still uncertain that the cosine of 0 is 1? Don't mess up on that. What about here? Well, I plug in infinity, it would become e to the slower over faster. So e to the slow over faster plus 3. Well, that ends up being e to the 0 plus 3. Oh, that's going to be 4. What about this? It's e to the sine of 1 over faster plus 2 looks like it's after. So this would be e to the sine of 0 plus 2. Sine of 0 is 0. E to 0 is 1. 1 plus 2 is 3. So just some interesting problems that might happen. Now, what happens here? Well, the negative x goes away. The 15 goes away. And then I can plug in infinity. Well, you might think it's like slower over faster, but it's not. It's the same growth over a same growth, because we know that the square root of x squared is just x. So what we have to think about is that we have this positive value getting plugged in times negative 2. So I have like a negative 2 times the same. In the denominator, I have this positive 16 times the positive root x squared, but it's the positive root 16. So it ends up like simplifying to be like 4x. But it's going to be a positive same because we have to be squaring the value and then square rooting it. So it ends up as an answer of negative 2. Now, we made a mistake here. This should be a negative, and this should be an x squared. Because the idea is if you do a negative infinity plugged in, it ends up being the same thing, only it's a negative 2 times a negative same over 4 times a positive same. Like the negative value being squared, the negative value being squared becomes a positive value. So I have like 4 times the positive same. So that ends up being, sorry, this should be negative 2/4 or negative 1/2. This should be positive 1/2. Here it's the same deal. The 8 doesn't matter. We kind of have 3x squared, but I'm not gonna worry about it right now because people get screwed up when they simplify. If you plug in a positive infinity, I'd have a 3 times a positive same over a 4 times a positive same, and I get 3/4. But when I plug in negative infinity, I'd have a 4 times a negative same, but in the numerator, I plug in the negative square it times 9 square root it. Well, it's going to be a positive same situation. This is how I say this is negative 3/4. So these square roots of squares, we just have to pay attention to signs. Okay, these next 4 are all about making sure you're looking in both directions. Because if I'm going in one direction, I will care about something. But if I go in the other direction, I might care about completely different things. Do we see why? If I'm going in the positive direction, this means nothing, this means nothing, this means nothing. And I'd have just this and this. However, if I go in the negative direction, I think I figured it out. I'm holding my thumb on the screen. That way it stays still. If I'm going in the negative direction, well, this all of a sudden becomes 0. This becomes 0. This is still no growth. And I just have that. So that's the thing we have to worry about when we're doing asymptotes, is depending on the direction, we worry about different things. If I go towards positive infinity, I would only care about the negative 3 to the x and the 4 to the x. This is a slower over faster. 3 times 3 times 3 times 3. 4 times 4 times 4 times 4. Slower over faster. 0. If I go in the other direction, well, now I wouldn't care about this because this is 0. I wouldn't care about this because this is 0. And I would just have the 2x squared over the negative 5x squared. It's a same over same. The growth will cancel. Does it really get negative 2/5 again? Look at that. Yeah, it didn't do that on purpose. If you get another negative 2/5, that's a problem. All right, so make sure you can see the reasons why. If I'm going in the positive direction, I'm not going to care about this. I'm not going to care about this. Slow over fast. Think about why slow over fast is 0 versus memorizing. Then if I go in the negative direction, this won't matter, this won't matter, and I get negative 4/8 because it's the same over a same. If I go in one direction for this one, I can see slow over fast. Slow over fast. Write out some fractions to help you remember why it is what it is. If I go in the negative direction, this is nothing, this is nothing, and this is the same over the same, or negative a half. Great. All right, now, changing gears, pay attention. What do I mean? Pay attention. Watch. I'm not plugging in infinity anymore. I'm not plugging in infinity anymore. I'm plugging in a number. When I plug in the number 5, I'm going to get something close to 0. However, besides understanding this is a vertical asymptote, we are going to want to understand a little bit more specifically what is the behavior of our function in this direction. We will look to think about plugging in a value that is a little bit bigger than 5. When you subtract 5 from that, you'll get a number close to 0 that is positive. Well, this negative 4 divided by something very, very close to 0 and positive is going to be very, very big and negative. And in the other direction, if I plugged in 4.999, I would end up with negative 4 over something close to 0. However, that number close to 0 would be negative, and I'd get a positive. What this provides us is a way to understand that at a vertical asymptote, to the left of the vertical asymptote, I'm going up. To the right of the vertical asymptote, I'm going down. It won't always be that way. We just have to figure it out. Okay, if I plugged in negative 1, I would get 1 over 0. If I plugged in negative 1, I would get positive 1 over 0. Cool, but let's pay attention to the 0. Is it a value close to, I'd get a value close to 1 over a value close to 0. But now let's pay attention to the sign of that 0. Negative 1 from the right would be like negative 0.999. If I take that value and add 1, it's going to be a little bit less than 1, which means it will be a positive. And that's why I see that my behavior to the right of negative 1 would be towards positive infinity. If I went to the left of negative 1, I'm thinking about negative 1.001. Again, I get a positive 1 in the top, or something close to positive 1, because it's negative 1 squared. I get a number close to 0, but in fact, it'll be close to 0 and negative, which is why I'm going to get negative infinity. If I plug in a number close to 3, I will get something close to negative 1 and something close to 0. Let's pay attention to this 0. I know to the right and left of 3 that I'm still going to get something close to negative 1. The sign is the sign for negative 1, whether it's to the right or to the left. It's really just the denominator that we have to worry about because the sign could change depending on the right or left. Well, if I subtract 2.9999, I'm going to have something positive, and we talked about how this is negative infinity. Cool. What if I plugged in something to the left of negative 4? Well, if I plugged in something close to negative 4, I'd have something close to positive 8. This squared would be a little bit bigger than 16. Subtracting 16 will give me something close to 0, but positive, which is why I'd say that's positive infinity. If I plugged in something close to negative 3, I'd get something close to negative 1, and I'd get something close to 0. Now, this we don't really care about because negative 3 to the right plus 2, negative 3 to the left plus 2 is close to negative 1, and negative 1 to the right or to the left doesn't change sign. We don't have to worry about. So we just have to worry about negative 2.999. Be careful with negative values and which direction is which. A lot of students make that mistake. If I take negative 2.999 and square it, it's going to be less than 9. 9 minus that would give us something close to 0 that's positive. That's why this answers that. Same thing. I'm sure I meant for this to be a negative. So this is going to be negative 1 over, this will be something a little bit more than 9. So this will be close to 0, but this is more than 9. That'll be that, and that'll be that. Okay? So that's fun. Now, did not get this to this in every class. These questions. These questions are very important questions. So please make sure you please make sure you do these questions and don't skip them. All right. We have a vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 2. Y equals negative 2. What must be true for A and B? All right. Well, we know vertical asymptotes occur when we plug in the value into the function and we get a number over 0. Okay, so when I plug in 3 into the function, I get 9a minus 3 over 4 minus b. Well, guess what? This equals 0 when b equals 4. I think I've just found b. Now, did I find a? No, I didn't, but let's use the other limit. The horizontal asymptote is at y equals negative 2. So that is when I plug in infinity, or negative infinity, into my function, think about growths, and my result will be negative 2. Well, if I was plugging in infinity, I would just ignore this and ignore this, and I'd realize I'd have a same over same situation, leaving us with just a. And this is how I get a equals negative 2. Great question. Try to do these. What a frustrating situation. What is this, like the PDF thing screwed this up? So add like a 5 here. It doesn't really matter. Okay. Vertical asymptote, x equals 2. So vertical asymptote, the limit as x approaches negative 2 of the function should leave us to a number over 0. So if I plug in negative 2, I get 3 times positive 8d over negative 8 minus 3c. Well, I know that bottom needs to equal 0 for us to have a vertical asymptote. So I get c is negative 8/3. Then the horizontal asymptote, which is at y equals 2, means if I plug in infinity into my function, I should get a result of positive 2. When you're plugging in infinity, it's all about fast growth. You can ignore the rest. You see you have a same over a same, so that growth would cancel, and you end up with negative d has to equal 2, d equals 2. Cool, last question. This homework honestly isn't that bad. Used to be one of like the biggest homeworks, but I feel like the continuity homework's worse than this one. We got a vertical asymptote at x equals 3. That means my limit as x approaches 3 of my function should give me some number over 0, positive or negative. Well, if I plug in 3, I get 3e minus 5 over 3d minus 7. This should be a number over 0. It will be when d is 7/3. And then the horizontal asymptote is at y equals 4, which means if I plugged in infinity into my function, I should get -4. When we're plugging in infinity, we don't care about the insignificant things. We just get ex over dx. That's a same over a same. That ends up being e over d. That has to equal -4. I know d is 7/3. So I can multiply both sides by d to get e equals -4 times d. So e equals -28/3 when I multiply 7/3 by d. Okay? All right, hope that video works. If not, my bad. I'll just make another one. Peace. Enjoy your long weekend.